Okay, so here I am to give you these solutions to the proving special quadrilaterals homework. Right before I get started, I just want to say I looked at a lot of the solutions and a lot of you did a really good job. I know these were not easy. They kind of took some ideas that we really haven't talked about, you really haven't seen before, and a lot of you did a really good job on them. So I want you all to watch this and um, and just see how these should shape up. Okay, so this first one, I want to apologize. I didn't put a letter in the middle uh, where the diagonals intersect. And there were two random letters on the side there. When I went to create the solutions, I realized that. So I'm just going to call it E. Again, feel free, if there's no letter at a vertex, you can add a letter just like you can number the angles. Okay, so feel free to add a letter if there's nothing there. I'm calling it E in my proof. Okay, so ABCD is a rhombus, and we're given that 1 is congruent to 2. All right, so AEB is a right triangle. Well, that's going to make 1 complementary to 2 because the acute angles of a right triangle are complementary. Okay, if one angle is 90, the other two angles must add up to 90. Okay, that's going to make 1 and 2 45 because um, congruent complementary angles must measure 45 degrees. Okay, if they add up to 90 and they're both the same, they must be 45. Okay, now I went on to 2 and 3 are congruent. That's a property of a rhombus. Okay, so the diagonal BD bisects angle ABC. So 2 and 3 are congruent to each other. The diagonals of a rhombus bisect the angles. All right, so that's going to make angle ABC a right angle, 90 degrees. They're each 45, okay, and they're congruent to each other. So you add them up, you get a 90-degree angle. So ABCD is a square because it's a rhombus with one right angle is a square. Okay, now we could have done this another way. We could have said that AE AE and BE are congruent to each other because sides opposite congruent angles are congruent. Okay, and then in any parallelogram, okay, not just a rhombus, ED would be congruent to BE, okay, because the diagonals bisect each other, and AE would be congruent to EC. Okay, and then I can add them together. AE plus EC equals DE plus EB by addition. Okay, then partition AE plus EC equals AC, and DE plus EB equals DB. Okay, that would be by partition, so that AC is congruent to DB by substitution. Now I've got a rhombus with congruent diagonals, which makes it a square. So you could have done it that way also. Okay, I chose to go with the, getting that right angle ABC. Okay, so either way would have been a perfectly legitimate way of doing that. Okay, so for this one, you needed to use the properties of a mid-segment. Okay, so what I did was AB is congruent to BC. That was given. Okay, that makes that an isosceles triangle, that big triangle. Okay, um, E, F, and D are midpoints. That was also given. Okay, now properties of the mid-segments. Okay, I said you need to use the properties of mid-segments of a triangle. The properties of a mid-segment say the mid-segment is parallel to the third side. So FD is parallel to BA, which makes it parallel to BE. Okay, and ED is parallel to BC, which makes it parallel to BF. Okay, so the mid-segments of a triangle are parallel to the third side. That makes it a parallelogram. Okay, EBFD, parallelogram. So a quadrilateral with two pairs of parallel sides is a parallelogram. Now, I didn't really need to state that, and I'll talk about why in a second, but I figured I would just show you that that you can get that to be a parallelogram. Okay. Now BE is half of AB and BF is half of BC. Okay, because they are by definition a midpoint, and FD is half of AB. Okay, and ED is a half of BC because the mid segments measure half of the third side. They're parallel to the third side, and they measure half of the third side. Okay, so I've got all four of them congruent to each other. Okay, halves of the same segments or halves of congruent segments are congruent. We already said A, B, and BC were congruent up at the top. Okay, and we're also taking halves of congruent and halves of the same segment. So all four of them are the same, so it's a parallelogram with congruent sides is a rhombus. Okay, you don't even need to say in this step that it's a parallelogram. As soon as you get a quadrilateral with four congruent sides, it's automatically a parallelogram and it's automatically a rhombus. So you really didn't need to say that it was a parallelogram in this case. You could have just said that the four sides were the same, and that would have been enough. Okay, so that's it. All right. So check your answers with these. Okay, and